The universe is expanding, but is it accelerating? The famous astronomer Edwin Hubble shocked the scientific community when he discovered that not only were there many other galaxies, but these galaxies had a Doppler shift, or more specifically a redshift. A Doppler effect is the apparent change in the frequency of a wave that is caused by the apparent motion between the observer and the source of the wave. In a star emitting light, you can see the waves of light moving from the star. Now, when that star moves, you can see the Doppler effect. When the observer is in front of the star that is moving towards the observer, the waves are bunched up and represent a higher frequency. And when the observer is behind the star moving away from the observer, the waves are more spread out and represent a lower frequency. We can't see these changes in frequencies with our naked eye, so therefore scientists use the visible light spectrum in order to tell if galaxies are moving towards us or away from us. Hubble realized that light coming from these galaxies were shifted towards the red end of the spectrum. The significance of red is that light from anything moving away from us appears redder due to the Doppler effect of redshift, similar to how an engine sound of a race car goes from higher pitch to lower pitch as it passes by us. So Hubble showed that every galaxy was receding away from each other at great speed in direct proportion to its distance, and this is described by Hubble's law, V equals h times d. In any case, this showed that the universe is increasing in size, and scientists have since been able to calculate the velocities of galaxies flying away from us at various time points. Since light takes time to reach us, when we look at different galaxies from different distances away, it can represent looking at the same galaxy at different time points. We can determine the velocities of galaxies at different times by observing Type 1a supernovas. A Type 1a supernova is an explosion from an old star that is 5 billion times brighter than our sun. The observed color and the observed brightness of the supernova can tell us two things about the galaxy it is in. Number 1, it's the speed. The redshift, z, of light tells us how fast the galaxy is moving away from us. The equation for redshift is z equals square root of c plus v divided by c minus v minus 1. So if the supernova is 1% redder than it should be, then its galaxy is moving at 1% the speed of light. 2. Distance, d, and thus directly time. The distance of how far away the star and its galaxy is from the observer can be calculated by comparing the observed brightness to how bright the supernova really is. As we move away from the star, the radiation it emits must cover a large surface area, and the intensity per unit area is decreased and obeys an inverse square relationship. So in essence, the brightness acts like a ruler to measure out how far away the galaxy is to us. Since light takes time to get to us, this is also a measurement of how long we are measuring this galaxy's speed. Once scientists measured the redshift and brightness of different supernovas and found the velocities at different distances or represented by different times in the past, they found that our universe is expanding faster than before and is accelerating like a fast red sports car.